Hi everyone, welcome to another video. This one's just a bunch of questions pertaining to modeling with algebra. So let's get started. Question 1 says to write an algebraic expression to represent each description. So double a number, 3 more than a number, half a number, and 2 less than triple a number. We need some sort of symbol to represent number. So I'm just going to let n represent a number. So double a number would be 2 times a number, right? So 2 times a number. 3 more than a number would mean that we have a number and we have 3 more than it. So if we had 5, it would be 6, 7, 8. So what we're doing is adding 3. Half a number, what do you do when you take half of something? You divide it by 2. So half of a number would be that number divided by 2. Or we could also write that as half times n. And 2 less than triple a number. So we have triple some number and then we're taking away 2. So we have 2 less than triple the number. So we're tripling our number and then we're taking away 2. So that's how we get that. Now we need to write an equation to represent each sentence and then solve the equation. So 4 times a number, we're still letting n represent a number, and that is going to equal 16. So 4 times some number is going to equal 16. And how do we solve this? Well, we need to solve for n, so we need to isolate n. But n is being multiplied by 4, so to get rid of a multiplying by 4, you need to do the opposite, which is dividing by 4. So we're going to divide by 4, but what we do to one side of the equal sign, we also have to do to the other side of the equal sign. Now these 4's will cancel, and n is equal to 16 divided by 4. And 16 divided by 4 is 4, so n is equal to 4. Part B says a perimeter increased by 13 is 57. So if we let perimeter equal p, then we have some perimeter that when you add 13 to it, so adding 13 equals 57. So let me just move this over here so we have more space. So we want to solve and isolate p. So we need to get rid of this plus 13. So we need to do the opposite, which is subtracting 13. So we need to subtract 13 from both sides. So when we subtract 13 from this side, it cancels. And 57 minus 13 is equal to 44. So P is equal to 44, or our perimeter is equal to 44. Part C says 3 more than triple a number is 27. So 3 more than triple a number. So let number be n. So we're tripling a number. So 3 times a number. And then we're doing 3 more than that. So we're adding 3 is equal to 27. So we want to isolate n, which is a part of this term. So we need to get rid of this other term, which is a positive 3. And we can do that by subtracting 3 from both sides. When we subtract 3 from the left side, it cancels with the positive 3. And we subtract 3 from the right side, we get 27 minus 3, which is 24. So now if we were to rewrite this, I wish I gave us more space, but if we were to rewrite what we have now, we have 3n equals 24. So to get n by itself, we need to divide by 3 on both sides. So dividing by 3 on this side cancels, and dividing by 3 on this side gives us 8. So n is equal to 8. Part D says the sum of 2 consecutive integers is 63. So an integer is a whole number like 1, 2, or 3, or -1, -2, even 0 is an integer. And it says that the sum of 2 consecutive integers is 63. So consecutive means one after the other. So 1 and 2 would be consecutive, 2 and 3 would be consecutive. -1 and -2 would be consecutive because they're right next to each other on the number line. So they differ by plus or minus 1. So if we let some integer be some number n, so if I were to draw a number line here, and we have some number here, and we have some number plus 1 and some number minus 1, then 2 consecutive integers could either be the n minus 1 and the n, or it could be the n and the n plus 1. So whichever one you prefer, it doesn't matter, to add together, and that's going to equal 63. So I'm just going to do n and n plus 1, but you could do n minus 1 and n if you'd like. So let me erase this. So n plus n plus 1 is going to equal 63. This positive sign doesn't affect anything inside the brackets, so I can just remove those brackets and get n plus 1 equals 63. Collecting like terms, this is the same as 2n plus 1 equals 63. To get rid of this 1, we need to subtract 1 from both sides. So if we subtract 1 from this side, it cancels. And if we subtract 1 from this side, it goes to 62. So we can rewrite that in the next line. 2n equals 62. And then to get n by itself, we need to divide by 2 on both sides. So over here, these are going to cancel, and we get n is equal to 31. Remember the consecutive integers, the first one was n and the second one was n plus 1. So now that we know what n is, we can plug that in into n plus 1 to solve for our next integer. So our next integer is going to be 31 plus 1, which is 32. So our two integers are 31 and 32, and if you'll check, they are consecutive. They come one after the other, and they do add up to 63. Question 3 says Stephanie is 2 years older than her sister. The sum of their ages is 44. How old are the sisters? So if I let sister equal S, and Stephanie is 2 years older than the sister, and we'll let Stephanie be T, then that means Stephanie, which is T, is equal to S plus 2 because she's 2 years older than the sister. So that's our first equation. Our second equation comes from the second part of the sentence. The sum of their ages is 44. So sum means adding. So when we add Stephanie and the sister together, we get 44. So our second equation is going to be Stephanie plus sister is equal to 44. If we get this equation in terms of one variable, we can solve for that one variable. So from our first equation, we know t is equal to s plus 2. So if we just replace this t with the s plus 2, since they're the same thing, we can get everything in terms of s. So that's what I'm going to do in equation 3. So s plus 2 plus s is equal to 44. And remember, we're using this in place of t. The brackets aren't affected by anything, so we can simply remove them. So s plus 2 plus s equals 44. Collecting like terms, we have two s's, so that's going to be 2s, and then we have a positive 2, so plus 2 equals 44. Now the variable we want to isolate is the s, and it's a part of this term. So we want to get rid of this positive 2, so we need to subtract 2. Now these will cancel, and in the next line we get 2s is equal to 44 minus 2, so 42. Now to get s alone, we need to divide by 2 on both sides. These would cancel, and we get s is equal to 21. Now that we know s is equal to 21, we can plug it into either of these equations to solve for t. So I'm going to do the first one because it's easier. So t is equal to s plus 2, and remember s is 21, so 21 plus 2. So t is going to be equal to 23. Now we can write our therefore statement. Therefore, Stephanie is 23 and her sister is 21. Question 4 says a new clothing brand has hired a model for its advertising campaign. The contract states that the model will be paid $6,000 per month during the campaign, plus $1.50 for each item of clothing sold. Part A asks us to write an equation that relates the model's total earnings in terms of the number of months, M, working on the campaign, and the number of S of clothing items sold. So our equation is supposed to model the total earnings. So we'll let our total earnings be T. So our model earns $6,000 per month during the campaign, plus $1.50 for each item of clothing sold. So our total earnings depends on the number of months that the model is doing the campaign and also how much clothing is sold. So our total earnings is going to be equal to $6,000 per month so $6,000 per month, so times the number of months. And we're also earning $1.50 for each clothing item sold. So we're also earning, so we're adding $1.50 per clothing item sold. So per clothing item sold is S. So now this equation basically is telling us that the total earnings is equal to $6,000 times the number of months. So $6,000 for 1 month, 12,000 for 2 months, plus $1.50 per sale of clothing. Now part B is asking us how much will the model earn after the first month of 1,200 clothing items sold. So for this, we're going to write down what we know so far. So there's only been 1 month of work. So our M is going to be equal to 1 for 1 month of model doing the campaign. Our number of clothing items sold is 1,200. So that's going to be our S. So now we can plug this into our total revenue equation to solve for our total revenue. So this is going to simplify to 6,000 plus $1,800 for a total of $7,800. And now we can write a therefore statement. Therefore, the model will earn $7,800 after the first month if 1,200 clothing items are sold. Part C says, suppose after 4 months on the campaign, the model has earned a total of $38,400. How many clothing items were sold? So let's write down what we know first. So we know that the model has worked 4 months on the campaign, so M is equal to 4. And we know that the total revenue is $38,400, so we know that T is equal to $38,400. What we don't know is S. We don't know how many clothing items were sold. So now we can plug this into our total revenue equation to solve for S. So T, which is $38,400, is equal to $6,000 times the number of months, which is 4, plus $1.50 times S, which is the number of clothing items sold. So we want to solve for S. So first let's simplify. So 6,000 times 4 is 24,000 plus $1.50 times S. S is a part of this term, so we want to get rid of this term, so we need to subtract 24,000 from both sides. When we do that, this will cancel here, and this will turn into 14,400. So we get 14,400 is equal to $1.50 times S. To get S by itself, we need to divide by $1.50 on both sides. And when we do that, this cancels here, the dollar signs cancel as well, and we get S is equal to 9,600. And now we can write a therefore statement. Therefore, 9,600 clothing items were sold. Part D says if the brand reaches a major milestone of 75,000 items sold, how much will the model have earned after 5 months? So we know M is equal to 5. We know that the item sold is 75,000. And we want to know how much they earned. So T is unknown. So we can plug all of this into our equation to solve. So T is equal to $6,000 times the number of months, which is 5, plus $1.50 times 75,000. And this one's easy, you just have to plug it in and solve. So 6,000 times 5 is 30,000, and $1.50 times 75,000 is $112,500. So adding these two together, we get $142,500 as our answer. And I'm too lazy to write a therefore statement right now, but you guys could figure that out. And finally, we are at our last question. So question 5 says, a circular fountain has a diameter of 8 meters. By how much should the diameter be increased to quadruple the area of the fountain? So let's write everything we know and everything we want to find out. So we have a diameter of 8 meters. So diameter is equal to 8 meters. By how much should the diameter be increased to quadruple the area of the fountain? So we want to figure out our quadrupled area, and then after we figure out our quadrupled area, we can then figure out what the diameter must be to get that quadrupled area. So first, let's figure out what our area is. So area of a circle is equal to pi r squared. So we only need to know our radius to figure out our area, but we know our diameter. And we know radius is equal to half of our diameter. So we can just divide this by 2 to get our radius. So our radius is going to be equal to 4 meters. Now that we know our radius is 4 meters, we can plug that into our area equation to find the area of our fountain, our original fountain. So our area of our original fountain is equal to pi times 4 meters squared. So when we solve that, we get pi and then 4 meters squared. So that's 4 squared, which is 16, and meters squared, which is m squared. And we typically write this as 16 pi meters squared. So this is just the area of our original fountain. So I'll write that down. Now we want to figure out by how much should the diameter be increased to quadruple the area of the fountain. So if we figure out what quadruple this area is, we can then figure out the radius needed to make it that big. And then once we figure out the radius needed to make it that big, we can figure out the diameter that was needed to make it that big. And then once we figure out that diameter, we can figure out how much bigger that diameter is from our original diameter. Okay, so that was a lot of talking, so let's just do it. So now I'm going to quadruple our area. So quadrupling means to multiply it by 4. So our area of our new fountain, so I'll call that area N for our area of our new fountain, is going to be equal to 4 times 16 pi m squared, which is going to be equal to 64 pi m squared. So this is going to be area of our quadrupled fountain. Now that we know the area of our quadrupled fountain, we can plug it back into the area of a circle formula to figure out what radius produced that quadrupled fountain. So 64 pi meters squared is equal to pi r squared. So to isolate r, we need to first get rid of this pi. So dividing by pi on both sides, and those cancel. And now we're left with 64 meters squared equals r squared. To get rid of this squaring, we can square root. So square rooting both sides. That would cancel here. And the square root of 64m squared is equal to the square root of 64, which is 8. And the square root of m squared, which is just m. So r is equal to 8 meters. So the radius that produced this quadrupled area is 8 meters. But we want to figure out the diameter that was used to produce this area. So remember, diameter is 2 times the radius. So the diameter is going to be equal to 2 times r, which is 16. So our diameter is equal to 16 meters. Okay, now that we know the diameter that was used to produce the quadrupled one, we can then compare it to the diameter that was used to produce the regular one, which is this 8-meter diameter. And we need to figure out the difference so that we can figure out how much we need to increase the diameter to get to this quadrupled one. So we're going to take the difference between the two diameters. So the diameter for the quadrupled one, which is 16 meters, minus the diameter of the regular one, which is 8 meters, is going to be how much we need to increase the diameter by. So this equals 8 meters. And make sure when you're answering word problems, you pay attention to what the question is asking you. And make sure you're answering the right thing. The question's not asking us what diameter produced the quadrupled area. It's asking us how much to increase the diameter by to get the quadrupled area. So that's why our answer is 8 meters. So always make sure you're paying attention to that. So now we can write our therefore statement. And there you go. Therefore, the diameter should be increased by 8 meters to quadruple the area of the fountain. Once again, I hope you guys enjoyed this video. Let me know what you want to see in the comments below, and I will see you shortly in the next one.